Fine. So screen is visible now. Yeah, screen is visible now.
Yes, sir.
Okay. So today, first of all, heading. Give a heading. Square planar complexes. Okay. Square planar complexes. So if I talk about square planar complex, we have two hybridization possible, right? Uh, it can be what? DSP2
Yes,
hybrid,
three.
DSP2,
Yes,
or it can be SP2D. Okay, these are the two types of hybridization actually possible for square planar compounds. Okay, suppose I am writing one of the square planar compound. Suppose you have this Ni Cn whole 4 2 minus. You have this compound nickel tetracyanide. Okay, so the oxidation state of nickel will be 2. Okay, and if you have nickel 2, so that means how many electrons are possible here?
3D.
3d8, right? So if I draw it, so 1 2 3 4 5, this is your 3d orbital, this is 4s orbital, and this is your 4p orbital. Okay, so this is 3d, this is 4s, and this is your 4p. Now if I talk about how many electrons you have, 8 electrons. And what is the nature of the ligand? So nature is your strong field. So if you have strong field, so that means what? Pairing will take place. Okay, pairing will take place, and when the pairing takes place, so what happens? Here you have one vacant d orbital, one s orbital, and here you have 3p orbitals. Now check how many ligands you have. So you have 4 ligands. Okay, 4 cyanide minus ligands you have, 4 cn minus. So each cn minus can donate 2 electrons, right? So cyanide will donate the electrons here one pair, here one pair, and the rest of the two pairs here. So what I am getting? 1 d orbital, 1 s orbital, and 2 p orbital. So that will become what? dsp2 hybridization. Okay, dsp2 hybridization. Okay, now suppose you have this metal, suppose you have scandium. Okay, then what you have? Titanium, vanadium, okay, chromium, manganese. So if you have these metals, so how many electrons is basically present in scandium? What is the electron configuration of scandium? 3d1 4s2, right? 3d1 4s2 means you have 3 electrons in scandium. Titanium you have 4 electrons. In vanadium you have 5 electrons. Chromium you have 6 electrons. Manganese you have 7 electrons. So if I talk about these metals, scandium, titanium, vanadium, so if you see how many electrons are present, only 3 4 5, right? So low number of electrons you are getting from the metal center. So that means what? Actually you require here more number of ligands. So write down more ligands, more ligands required, more ligands required to get 18 electrons. Okay, suppose you have 4 electrons from the metal center, so that means almost 14 electrons needed from your ligand center. Okay, and more ligands required to get 18 electron, that is fine. But if more ligands appear there, suppose more ligands, 5 to 6 ligands are coming, 6 to 7 ligands are coming to the metal center, so that time what will happen? Steric repulsion generates. Steric repulsion generates. So these are the two things you have to keep in mind. So if you have transition metal of 3d series and they have only 3 4 5 electrons, so that means more number of ligands required to get this 18 electron compound. But once the suppose 7 ligands appear for a particular metal center, so that time one thing also comes, that is your steric factor. Okay, so steric repulsion also generates there. Okay, fine. Okay, fine. So these are the things we will go one by one. So now we will come to the example of 18 electron rule. Okay, what we have started yesterday. So what we have, suppose you have this compound. This is your cyclopentadienyl molecule. It is now attaching to iron center. Okay, and here also I have cyclopentadienyl molecule. Okay, so basically try to count down the number of electrons in neutral method. Okay, try to count down in neutral method. Okay, tell me how many electrons are present. So if I talk about neutral ligand, okay, see, first of all, so this is what, this is your cyclopentadienyl, right? So how it exists basically, cyclopentadienyl is actually existing like this. If it is showing like this, a circle, and then it is attaching to the metal center, so that means all the carbon centers are basically attaching to your metal center. So that means resonance is already happening here. Okay, resonance is involving here. So how many electrons it is donating? 6 electrons. Okay, so 6 electrons from this cyclopentadienyl. From this cyclopentadienyl, 6 ligand, 6 electrons, and now iron. Okay, sorry, 6 ligands, no need to. This will be your ionic method. If I bond it like so, that will be ionic method. Sorry. You can think about ionic method also. Okay, first of all I am talking about ionic method. Okay, so ionic method, it will donate 6 electrons, it will also donate 6 electrons. And if I am writing like this, basically if I am writing like this, negative charge here, so that means this bond breaks like this. Okay, and this bond also breaks like this. So that time cyclopentadienyl anion is giving 6 electrons, that is fine, but iron is now becoming iron 2 plus. So if you have iron 2 plus, what configuration you will have? 3d6. 3d6 electronic configuration you will have. So basically 6 electrons from iron 2 plus, 6 electrons from your cyclopentadienyl, 6 electrons from another cyclopentadienyl unit. So this is your ionic method. Okay, this is your ionic method. But if I actually prefer neutral method. If you see in neutral method, so think it homolytic cleavage. Okay, so that time no charge generation, so that time it will be homolytic cleavage. So 2 electrons from here, 2 electrons from here, 4 electron, and 1 electron it will get from this carbon center. So 5 electron from this unit, 5 electron from this unit, and iron, here iron is present in 0 state. Okay, iron is present in 0 state. Okay, iron 0. So that means what? 3d6 4s2. How many electrons you have from iron center? 8. So 5 plus 8 plus 5 is equal to what? 18 electrons. Okay, so you can do any of the, you can follow any of the method. You can follow neutral method, you can follow ionic method, but keep in mind, if you are following ionic method you have to do heterolytic cleavage. If you are following neutral method you have to do homolytic cleavage. Okay, done. Understood?
Yes, sir.
Understood. Okay, suppose I have this. Okay, now no need to do by both the methods. You just follow neutral method, that will be enough. Okay, try to follow your neutral method, that will be enough. Okay, so do it.
Here, manganese oxidation state 3D4.
Hmm?
3D4.
What? Manganese, how many electrons you are getting
3,
from
3,
manganese?
3D4, sir. Oxidation state plus 1.
No, I am asking about neutral method. No need to find out the oxidation state. Consider manganese is 0. Neutral method. Suppose you have this manganese 0. So how many electrons?
3D5 for us to.
3d5 4s2. So that means 7 electrons you are getting from manganese center. Okay. Now think about this methyl CH3. So CH3 will donate how many electrons if you follow neutral method? Neutral method means what? Homolytic cleavage. Okay, if you do homolytic cleavage of this carbon manganese bond, so this methyl will donate 1 electron,
1,
and carbonyl will donate how many electrons? Each carbonyl?
5.
Huh?
1, 5, sir. Here, 5.
Carbonyl donates. Carbonyl is
1,
what?
neutral.
Neutral ligand. So this is the carbonyl, na? You have a lone pair which is donating actually. Okay. Think about carbonyl. Carbonyl means what? Carbon oxygen double bond. So carbon has total 4 electrons, 4 valence electrons. 2 electrons are involved in bonding, 2 electrons left here. Oxygen has total how many electrons? 6 electrons. So 2 electrons here involved in bonding, 2 electrons here, 2 electrons here, 6 electrons. Now if oxygen donates the lone pair, that time it will looks like this. So basically carbon is donating this lone pair. In CO, carbon is donating this lone pair. So that means basically carbon donates 2 electrons. This CO, carbonyl actually donates 2 electrons. How many carbonyls you have? 5. So 2 into
10.
5. So 10 plus 1, 11 plus 7, 18 electron. Clear?
Yes, sir.
You can do ionic method also. So if you do ionic method, that time it will do heterolytic cleavage and manganese will become plus 1
Plus
oxidation
1.
state. Okay. So that time manganese plus 1, you will get 6 electron from here.
Yes, sir.
CH3. CH3 will get a negative charge, so that times it will donate 2 electrons. And from the 5 carbonyls, you will get how many electrons? 2 into 5. So here also you will get 18 electron. Okay. Uh, so same number of electrons you will get, but the process is different. This is your neutral method and this is your ionic method. Clear?
Yes, sir. Clear.
Okay. Next I am coming to this Cp2CO. Do it. Any method you can follow. Neutral ionic. So Cp2CO means what? Cp means what? Cp means what? Cyclopentadienyl, right? Cp means what? Cyclopentadienyl. Okay. This is the molecule they have given you. So if you follow neutral method, so 5 electrons from this Cp unit, again 5 electrons from this Cp unit, and cobalt is what? Cobalt is neutral. Consider cobalt as a neutral. So cobalt is what?
3D7 for us.
3d7 4s2. So how many electrons you will get from cobalt
9.
center? 9
9.
electrons. Add them. So what is the electrons you are getting? 19
19.
electron. Okay. If you have this Cp2 cobalt plus Cp2CO plus, How many electrons?
18 electrons.
18 electron, right?
Yes.
So from 2 cyclopentadienyl we will get how much?
10
2 into 5.
10
Okay,
electrons.
cobalt I will get 9
8
electron,
electrons.
and from this positive charge I will get minus 1. Positive charge means what? 1 electron left, right? Minus 1. Sorry. This positive charge means what? Positive charge means 1 electron left. So minus 1. So overall we are getting 18 electron. Okay. Smita, Sampriti, clear?
Yes, sir. Understand.
Sampriti, clear? Okay, what about this FeCO whole 5? Check in neutral method.
18 plus.
How much
8.
electrons?
18 electrons.
18. So iron is 0. So iron 0 means what? 3d6, 4s2.
3 4s.
8 electron from iron center.
Then
And
10
carbonyl,
electrons
yeah.
from carbon.
Carbonyl is donating 2 electrons. You have 5 carbonyls. So 2 into 5. 10 plus 8, 18 electron. Okay? Done.
That's it.
Okay. Next, suppose you have this FeCO whole 4 2 minus. FeCO whole 4 2 minus. So iron is donating how? Okay, find it out. In neutral method you can find it out.
Fourteen electrons.
Hmm?
14 electrons.
14 electron check. 2 minus, negative charge. So negative charge means you have to add electron. Iron will donate how many electrons? Iron follow neutral method. So iron will donate 8 electron.
8 electrons.
Carbonyl, you have 4 carbonyl. So 4
8
carbonyl means
electrons.
what? 2 into
4.
4, 2 into 4, and you have now 2 negative charge. So for 2 negative charge you have to add 2 electron. Okay, this is not a positive charge. If you have a positive charge you have to subtract. If you have a negative charge you have to add it. Okay, so 8
Okay.
plus 8, 16 plus 2, 18 electron. Clear? Clear?
Done. Yes.
Okay, do this. Find out. How many electrons? So first of all, tell me about rhodium.
Donates 9 electrons.
Rhodium,
Donates 9 electrons. 348 AS4.
how many electrons? Rhodium?
9
9,
electrons.
right? Yeah, 9. So cobalt, rhodium, iridium, right? So they are
Yes, sir.
all the same group members. So 3d7 4s2, right? 3d7 4s2 means 9 electron from rhodium center. Now it comes to pph3. pph3 donates how many electrons?
Neutral ligands.
Neutral ligand. How many electrons it is donating?
One
Again,
mono delegates. Mono.
phosphorus has how many valence electrons?
5.
5 valence electrons. So you have 3 phenyl rings. So that means 3 electrons are already involving, na?
Yes, sir.
3 electrons are already involving in chemical in covalent bond, right? How many electrons left?
2 electrons.
2 electrons. So that 2 electron it will donate. So pph3 will donate 2 electrons. How many pph3 you have? You have 3 pph3. So multiply by 3. Okay.
Yes, sir.
And chlorine will donate how many electrons? 1 electron.
1
If then
electron.
writing suppose chlorine is not acting as a bridging ligand, that time it is acting as a terminal ligand, so that times it will donate only 1 electron. Okay, if it is acting as a bridging ligand, so that time it can donate more than 1 electron. Okay, so how many electrons I am getting? 9 electron from rhodium center. From this 3 pph3 ligand I am getting 6 electrons. So 9 6 15 plus 1, how many electrons we are getting? 16
16
electron.
electrons.
Okay, done.
Done, sir.
Okay, Smita, understood?
Yes, sir.
Understood, right? Any doubt, tell me, huh? Sampriti, done? Okay, fine. Okay, suppose you have this pt cl3 c2h4, pt cl3 c2h4 minus. Okay, pt cl3 c2h4 minus. Count it. How many electrons you are getting? Check it. Consider neutral method. Okay,
Sixteen, sir. 16, sir. 16.
16. 16. So platinum donates how many electrons?
Platinum donates 10 electrons.
10 electrons. Fine, 10 electrons. Chlorine donates
C2H 1.
1 electron. You have 3 chlorine, so it will be what? 1 into 3. C2H4.
Yes, sir. 2 electrons.
C2H4 means what? You have double bond, right? Ethylene molecule CH2, double bond CH2. So it is donating the electrons from the pi bond. So C2H4 donates 2 electrons. C2H4 donates 2 electrons. Okay. And
Then
I
one
forget, you
minus
have a
charge.
negative charge, right? So for negative charge you have to add 1 electron. So now see, 2 1 3, 3 and 3 6 plus 10, how many electrons we are getting?
16 electrons.
16 electron. Okay, 16
Yes.
electron. Done.
Done.
Fine. Find out. How many electrons you are getting here?
18 electrons.
18. So the cyclopentadienyl,
5.
5 electrons, right? So
Yes, sir.
cyclopentadienyl is donating 5 electrons. Copper,
Don- Copper donates 11 electrons.
9 electrons. CO,
CO2 electrons.
2 electrons. So 5, 9, 14 plus 2. How many electrons? 16. Right?
Yes.
Sorry, copper will be 11, na?
11.
Copper will be 11. Copper is what? 3D
3D10
10,
plus 1.
4s1, right? Copper will donate 11 electrons, so it will be 18. Okay.
Yes, sir.
Okay, now count here how many electrons are there. Okay, turn off the mic, huh? Turn off the mic, otherwise in recording the sound will come, huh?
16 electrons.
16 electron, right? So
Yes, sir.
again cyclopentadienyl will donate you 5 electrons. Now manganese is what? 3d5 4s2. So 3d5
7.
4s2 means 7 electron, and you have 2 carbonyl. So from 2 carbonyl you will get how many electrons? 2 into 2 electron. So 5 plus 7 12 plus 4 16 electron we are getting. Okay, fine. Now suppose you have next this. So here you have cyclopentadienyl. Now you have chromium, and here you have 3 carbonyl. Okay, find it out how many electrons you are getting. Hmm?
17.
17, right? So this cyclopentadienyl will donate 5 electrons. Chromium means what? 3d5 4s1, right? 6 electron from here, and from this 3 carbonyl you will get 6 electrons. So 5 6 11 plus 6 17 electron. Okay, good. Now suppose you have this chromium CO whole 3 NO whole 2. Find it out.
18.
18, right?
Yes, sir.
So chromium is donating how many electrons?
6 electrons.
6 electron. From 3 carbonyl you are getting how many electrons?
6 electrons.
6 electrons. And from 2 NO,
3, 1 electron. And
huh?
more donates 3 electrons.
How many electrons?
Sir, NO donates 3 electrons. So here we have to.
2 into 3, right?
Yes, sir. Yes.
So if you do this, you are getting 18 electron. Now NO donating 3 electrons, so that means which kind of NO? It is linear or bent?
Linear.
Linear, okay. Linear. Now you can ask me that, sir, why you are not considering here bent NO? So if you consider the bent NO here, so chromium is donating 6 electron, that is fine. From the 3 carbonyls, you will again get 6 carbonyls, okay, 6 electrons. But if you consider here bent nitrosyl, so bent nitrosyl donates how many electrons? 1 electrons, right? So 2 into 1. So here you will get 6 plus 6 12 plus 2 14 electron. Now that is actually not stable. Okay, this 8, if you are getting 18 electrons, so that becomes much more stable. Okay, this is more stable. This one is actually most stable. This one is not stable. That's why we are considering linear NO, not bent NO. Okay, done.
Yeah.
Suppose you have this. Do it. How many electrons you are getting? How many electrons you are getting here?
18, sir.
18. So molybdenum donates how many electron?
6 electron.
6 electron. The cyclopentadienyl donates
5 electron.
5 electrons. This ring,
3 electron.
this ring donates 3 electron. Okay. What about linear?
3 electron.
Linear nitrosyl is donating 3 electron, and bent nitrosyl
1 electron.
1 electron. Okay, so if we add now, so 6 5 11 3 14 3 17 plus 1 18 electron.
Yes.
Done. Done.
That's it.
Okay. Now suppose you have this chlorine, here you have ruthenium, here also you have chlorine, here you have PCUI3, here also you have PCUI3, here you have double bond, hydrogen, pH. Yeah, tell me total number of electrons.
sir.
How many electrons?
16.
16. Okay. So ruthenium is donating how many electrons?
8 electrons.
8 electrons. Fine. Chlorine will donate
1 electron.
1 electron. You have 2 chlorines.
2 electrons.
So that means 1 into 2 electron. Okay. Now what about PCY3?
And yes, sir, 2 electrons.
2
1 will
electrons.
donate to the
Again same thing.
3.
Phosphorus is doing bonding with 3 cyclohexyl rings. So that means 2 electrons left here that it will donate. So 1 PCY3 and PCY3 and PPH3 is same, right? So
Yes,
PCY3 is
sir.
donating 2 electrons. You have 2 PCY3. So 2 into 2 electron, and from this double bond, if
2
I consider
electrons.
neutral method, yeah, if you consider neutral method, so this double bond will donate 2 electrons. So 8, 2, 10, 4, 14 and 2, 16 electrons.
16.
Okay, good. uh, Next, suppose you have this Cp, Fe, Co, PPH3, CF2. So basically this is the cation part and this is the anion part. No need to worry about the anion part. You have to find out the total electron count from this cation part only. Okay, do it.
The 19. Sorry,
9,
18. 18, sir. Plus 1. 18, sir. 18
18, right? Yeah.
electrons.
So cyclopentadienyl is donating how many electrons? 5 electrons.
5 electrons.
Iron,
8 electrons.
iron 8. Okay.
2
Carbonyl,
electrons.
2 electron. PPH3,
2 electrons. 2
2
electrons.
electron.
Add to
CF2,
2. Yes, sir. 2 electrons.
CF2, 2
2
electron.
electrons.
2 electron, correct. So how to check? So you have this CF2. So carbon has total 4 electrons. Already it is making bond with 2 fluorines. So that means 2 electrons left that it will donate. So like that you have to check. And for positive charge you have to subtract 1. So 5, 8, 13, 2, 15, 17, 19 minus 1, 18 electrons. Okay, good. Okay, very good. Now let's try this one. Suppose you have iridium DPPE. Okay, DPPE whole 2 plus. What is DPPE? What is DPPE? Write down. Diphenyl diphenyl phosphine phosphine ethane. Diphenyl phosphine ethane. So it basically looks like this. Okay, so you have 2 phenyl rings here. Okay, 2 phenyl rings are here attaching with the phosphorus center. So diphenyl phosphine ethane. So phosphorus will donate how many electrons?
2 electrons.
2 electrons, because it has 5 valence electrons. 3 bonds already it is forming. So these 2 electrons it will donate, and this phosphorus will also donate 2 electrons. So basically 1 diphenyl phosphine ethane, 1 DPPE unit, 1 DPPE unit is donating how many electrons? 4 electrons to the metal center. Okay, so now do it. Iridium means how many electrons?
9 electrons.
9 electrons from iridium center and 2 DPPE unit. So one dpp is donating 4 electrons. If you have 2 dpp, so it will be 2 into 4 electron, and for this positive charge you have to subtract 1 electron. Okay, so what I am getting, 9 plus 8, 17 minus 1, 16 electron. Okay,
Yes, sir.
done.
Done, sir.
Smita done. Any doubt?
No, sir.
Clear na? Okay. Suppose you have this. Do it. Total electron count. Done. How many electrons? How many electrons you are getting here?
18 electrons.
18. So chromium is donating how many electrons?
6
6
electron.
electron. This benzene
Benzene
ring.
donates 6 electron.
Hmm. Benzene you are getting 6 electron, and from this 3
And
carbonyl
carbon 6 electron.
you will get 6 electron. So total I have 18 electron here. Okay, good. Now suppose you have this. You have 5-membered ring here. Huh. In this example, tell me.
Eighteen, sir.
18.
Yes, sir.
So you have cyclopentadienyl CP unit. CP will donate how many electrons? 5
5
electrons.
electrons.
Iron.
Iron
Iron
donate 8 electrons.
8 electron. This methyl will donate
1 electron.
1 electron, and from this 2 carbonyl you will get
4 electrons.
4 electron. So 5 8 13 plus 1 14 plus 4 18 electron. Okay. Suppose you have this CP CO whole 3 NO. CP CO whole 3 NO. Find it out.
Fourteen electrons.
How much?
14.
14.
Yes, sir.
14 how you are getting? So cyclo, I missed something.
Yes, sir. You missed the pencil.
Okay, sorry, I did it wrong.
Yes.
Okay, sorry. This is not Cp, this is your cobalt, huh? Co.
Okay.
Now check.
18, sir.
18, right?
Yes, sir.
So cobalt is what? Cobalt is your 9
9
electron. Carbonyl will donate 2
7.
electrons. You have 3 carbonyl, so 2 into 3 electron. So see, 9 plus 6, 15 electron you are getting. So if you take NO as linear, so it will donate 3 electron. And if you are getting 18, so that means it's more stable. Okay, and this, so that means what? This nitrosyl is basically your linear nitrosyl here. Okay, so it will donate 3 electron. Okay,
Yes, sir.
okay, fine. So you have nickel, eta 5 Cp, NO. Do it.
Eighteen, sir.
18. So nickel is what? Nickel
28 for us.
10
10
electron,
electrons.
right?
Yes,
Cp
sir.
will donate how many electrons?
5 electrons.
5 electrons, and NO will donate
3 electrons.
3 electron. Sorry, this is not bent, this will be a linear. Okay, linear, so it will donate 3 electrons. So again you are getting 18 electron. Okay, good. Now suppose you have this. Do it. So how many electrons you are getting?
So 24, sir.
Yeah, how many?
24.
24. No, here you have 2, no? Here you have 2 cobalt centers. So if you have 2 cobalt center, How many you will
Yes,
get?
sir. 18 electrons.
2
One
into
robots
9.
on 18 electrons.
For 2 iron center,
Yeah, 16 electrons.
2 into 8. Yeah. You have 11 CO. So 11 CO. That means what? 2 into 11.
Okay, but
What
I
left?
thought it was two second.
See, so how many metal centers are present here? Two cobalt center and two iron center,
Oh,
right?
I
Total you have four metal centers, and you can see here they have written mu4. So mu4 means what? This ligand is actually a bridging ligand, and that is actually attaching with the four metal centers. Okay, now the question is, what is pph? How many electrons pph will donate? So if
two
you have
electrons.
pph, how many electrons it can donate?
4 electrons.
4 electrons. So phosphorus has 5 valence electrons. Out of this 5, 1 electron is already involving in covalent bond formation. 4 electrons left. So it will donate this 4 electrons. So 1 pph unit, okay, is donating 4 electrons. You have 2 pph unit, so it will be what? 4 into 2. So now add them, what you are getting. So 18 plus 16, 34 plus 22, so it will be 56 plus 8, so 64 electron. Okay, 64 electron. Done. Understood?
Understood.
Smita, understood this one?
Yes, sir.
Done, right? Okay, now suppose you have this. Here you have tungsten, here you have eta 5, C5H5. Okay, next you have mu Cl, CO whole 2, and now this thing is overall whole 2. Okay, so first of all, better write down like this, that WO2, then what, eta 5, C5H5 whole 2, then you have mu Cl whole 2, and that one will be what, CO whole 4. Okay, now count down the electrons.
One to six.
What you are getting?
1 to 6.
26.
Yes.
26. So 2 tungsten will donate how many electrons?
Sorry, 12 electrons. Yes, 1 electron.
2 into 6
12
na?
electrons.
Okay, 2 eta 5 C5H5. So this is what? This is your CP, cyclopentadienyl. C5H5 means what? CP unit. Cyclopentadienyl ion. So it will donate 5 electrons.
5 electrons.
So it is what? 2 into 5. Now mu Cl. Mu
2
Cl. If
electrons.
nothing is there, so that means what? Mu 1. Okay, so now write down the chlorine structure. So it is already doing bridging, so that means chlorine is already attaching with two metal centers. So first of all, think like that, suppose you have this bond, metal chlorine bond, because this is terminal bond. I already told, first of all, every bridging ligand, first of all it will be your terminal ligand. So 1 electron is involving in this. How many electrons left? 6 electrons left. Now this lone pair is donating to the other metal center. So overall it is donating 3 electrons. This mu Cl, overall it is donating 3 electrons, and you have 2 mu Cl, so that means it will be 3 into 2 electron. And now you have 4 carbonyl, so it will be 2 into 4 electron. Clear?
Yes, sir.
So this is terminal bond. Terminal bond means it is donating 1 electron, and this lone pair is donating to the other metal center. So overall it is donating 3 electrons. Okay, so if you add them, so 2 into 6 12 plus 10 22, 22 plus 6 28, 28 plus 8, it will be 36 electron. Okay,
Yes.
clear how to do? Clear? Any doubt? Tell me. Smita, clear?
Yes, sir. Clear.
Clear, right? Okay, now next, try to this one correctly. Okay, this example try to do correctly. CO whole 4 vanadium mu Pr2 whole 2 vanadium CO whole 4. Okay, do this one. Fine. So tell me how many electrons you are getting here?
32, sir.
32, yeah, correct. So basically you have first of all two vanadium center. So if you have two vanadium center, so how many
10
electrons I will
electrons.
get?
10 electrons.
10 electrons. So vanadium means what? 3d3 4s2, right? 5 electrons from each vanadium. So 2 vanadium is donating 10 electrons. Now total you have 8 carbonyls. So if I have 8 carbonyls, so what? 2 into 8, that much electron. Okay, and what left here? Pr2. Pr2, write down
3
Pr2
electrons.
like this. Okay, write down Pr2 like this. So that means I have two electrons are already involving this bond, right? Two electrons
Yes.
are already involving in this covalent bond. So how many electrons left? 3
3
electrons
electrons.
left. So that means it is donating 3 electron.
Electrons.
Okay, so this mu pr2 or pr2, okay, it is donating 3 electrons. You have two units, okay, 2 moles of this, so it will be what? 3 into 2 electron. So how many electrons? 10 electrons from here, 16 from here, and 6 from here. So
32.
together it will donate 32 electrons. Okay, done.
Yes.
Hmm.
Done.
Okay, fine. Now suppose you have this Cp, ruthenium, chlorine, CO, pph3. Okay, now find out how many electrons. So how many electrons?
18.
18. So cyclopentadienyl will donate how many electrons? 5 electrons. Ruthenium,
8 electrons.
8 electrons. Chlorine,
1 electron.
1 electron. CO,
2 electrons.
2 electrons. And ppH3,
2 electrons.
ppH3 also 2 electrons. So if I add, how much I am getting? 5, 8, 13, 1, 14, 16, 18. 18 electron. Okay, fine. Now suppose you have this tungsten CO whole 3, okay, SiMe3, chlorine, here you have this NCMe whole 2, NCMe whole 2, okay. Find out this one. रुको थोड़ा 7:30 तक फिर क्या करूँ, जाऊँ अभी, कर दूँ बंद, बैठो थोड़ा, बैठो हाँ थोड़ा बैठो 5 मिनट, खाता हूँ, बैठो इधर बैठो, हाँ ठीक है जाता हूँ, रुको 5 मिनट रुको, थोड़ा बैठो, ठीक है रुको, फिर ये करता हूँ, फिर छुट्टी देता हूँ। हो गया है बैठो, हो गया बैठो, हो गया बैठो, अरे रुको ना, ये देखो और इतना सारा है, देखो एक ये हो गया, 1 2 3 4 बस। रुको थोड़ा, okay done, this one done. So tungsten will donate how many electrons? 6 electron. 3 carbonyl will donate how many? 3 into 2 electron, 6 electron. Now SiMe3. So first
1
of all,
electron.
so 3 bond already present. Already you have 3 silicon methyl bond, so 1 electron left. So SiMe3 donates 1 electron. Chlorine will donate
1
1
electron.
electron. And now you have this CNMe. So CNMe means what? How it looks like? So it looks like this: nitrogen, triple bond, carbon, bond, methyl. So nitrogen is the donor atom. How many electrons it will donate? How many electrons
2
it will donate?
electrons. 2 electrons.
2 electrons. So basically this unit NCMe, okay, you have 2 NCMe, so it will donate 2 into 2 electrons. So what we are getting? 6 plus 6 12 13 14 plus 4 18 electrons. Clear?
Yes.
Okay. Now suppose you have this iridium Cl3 ppH3 whole 2 As pH2 whole minus. Try to do it. So everything you know except this arsenic pH2. So draw the structure AsPH2. So AsPH2 means this, right? So basically they have 5 valence electrons. Already 2 electrons are involved in bonding. So it is donating how many electrons? 3 electrons. 2 electrons this, and this is your one odd electron. So iridium will donate how many electrons? 9. 3Cl will donate how many electrons? 3
3 electrons.
electrons. PPH3 will donate how many electrons?
2 electrons.
2 electrons. You have 2 PPH3, so it will be 2 into 2. And next you have AsPH2, it is donating 3 electron, and you have one negative charge. So for this negative charge you will get 1 electron. So how much we are getting? 9 3 12, 12 plus 4 16, 16 3 19. So sorry, negative charge, right? Okay, so negative charge means you have to you have to add 1 electron, right? So I have done something wrong. AsPH2, yeah, nitrogen, phosphorus, arsenic. So basically AsPH2. So nitrogen has 5 valence electrons. 2 electrons are already involving here. Okay. Two electrons are already involving here. Here you have 3 electrons. So 3 electrons are there. Hmm. Okay, so here this ligand na AsPH2, this AsPH2 will donate 1 electron. Okay, it will donate only 1 electron. Now why it is donating 1 electron? Because here we have only one metal center. Okay, we have only one metal center, iridium. So basically with iridium it is donating 1 electron. Okay, it will not donate this lone pair here. Okay, so this AsPH2 you can write down 1 electron. So yeah, then you will get 18 electron. If you have more than one center, more than one ligand center, more than one metal actually, that time it can donate. Okay, but yeah, if you donate here, basically you can check like this. If it crosses 18, so that means it is not donating all of its electrons. Okay, it is donating only one electron. Okay, if it donates all the 3 electrons, then it is becoming 20, right? It crosses 18 value, so that's why you have to do like that. Okay, it is donating only one electron, not all the 3 electrons. Okay, fine. Any doubt?
Yes, sir. Understood.
Okay, now suppose you have this osmium, nitrogen, Br2, PMe3, okay, NMe2, and here you have a negative charge. So this thing I am doing. Okay, so if you have this kind of compound, so arsenic and osmium, and they are writing, then they are writing nitrogen, so basically they have triple bond. Okay, they have triple bond. So osmium is donating 8 electrons. Okay, nitrogen, this is a neutral method, so nitrogen is donating 3 electrons through this covalent bond. 2 bromine will donate 2 electrons. Okay, PMe3, this PMe3 unit is donating 2 electrons, and last you have NMe2. Okay, so here also you can see, if you donate NMe. Okay, so basically 2 electrons are involved in this bonding, so that means 3 electrons left. But if you see, so osmium 8, so 8 3 11 2 13 2 15. Okay, 15, and you have a negative charge. So for this negative charge negative charge, you will get 1 electron. Okay, so check how many you are getting now. So 8, 3, 11, 2, 13, 2, 15, 1, 16. Okay, 16. And see, if it donates all the 3 electrons now, if nitrogen donates all the 3 electrons, so it will cross 18. Okay, it will cross 18. So basically it's not possible, it cannot donate all the 3 electrons. So here also it will donate 1 electron to the osmium center. Okay, the lone pair it is not donating. So if it donates 1 electron, so that times the total value will be what? Total value will be your 17 electron. Okay, so you have to check like this whether it is crossing 18 or not. If it is crossing 18 value, so that means it is not donating all the electrons. Okay, and why it is not donating the lone pair here? Because you have only one metal center. Okay, so it is donating first of all, keep in mind, each ligand or every ligand will act as a terminal ligand. Okay, you can ask me, sir, why it is not donating the lone pair? So keep in mind one line, that every ligand is terminal. So first of all, it will donate one odd electron, then only it can donate its lone pair. Okay, but if it has option, definitely it will donate one electron first of all, and that's what your terminal ligand. Clear? Done?
Yes, sir. Clear, sir.
Okay, now next, suppose you have this nitrogen, here you have CH3 hydrogen. Okay, it has a lone pair, it is donating the lone pair to the molybdenum center. You have this. So now tell me total electron count. How many electrons?
13 electrons.
13. How you are getting 13? Molybdenum
186 electrons.
6 electron. This ligand is donating how many electrons? CH3 whole 2 NH. This is donating how many electrons? 2 electrons,
2
na?
electrons.
And CO will donate how many electrons?
2
Carbonyl
electrons.
2 electrons. So overall how many electrons? 10 electrons.
10 electrons.
Okay, how you are getting 13? This is carbonyl, na? Carbonyl is a neutral ligand, it is always donating 2 electrons. This nitrogen is also donating 2 electrons. So 4 electrons is coming from the ligands, and molybdenum has 6 electrons, so total it has 10 electrons. Done?
Yes, sir.
Okay. Next you have, suppose this molybdenum CO whole 3 PCl PH2 whole 3. So all the things you know, first of all write down this ligand PCl PH2. So that means you have phosphorus, you have chlorine, and 2 phenyl bond. Phosphorus has 3 bonds, one is attached with chlorine and 2 attached with phenyl. So how many electrons left?
2 electrons.
2 electrons. So it will donate how many electrons?
2 electrons.
2 electrons it will donate. So write down now, molybdenum has 6 electrons, 3 carbonyl has how many electrons? 2 into 3 electron, and that molecule, what is that? PCl PH2. You have 3 units of this PCl PH2, so that will donate how many electrons? Again 2 into 3 electrons. So 6 electron from here, 6 electron from here, 6 electron from here. Overall how many electrons? 18 electrons. Clear?
Yes,
clear? Molybdenum is donating 6 electrons. From 3 carbonyls you are getting 6 electrons, and from this 3 phosphorus ligand you are getting again 6 electrons. So overall you are getting 18 electrons. Okay, fine. Now suppose you have this. Tell me how many electrons you are getting from here. Hmm? 18. Check. Manganese has how many electrons? Manganese? Hmm? 7 electron. 5 carbonyl. 2 into 5. Hydrogen will donate how many electrons? 1 electron, and you have a negative charge. So what? 1 electron. So 7 plus 10, 17, 18, 19 electron. Here you have no option, so that's why it is crossing 18 value. Okay. Clear? Smita, clear? Smita, clear? She is not there. Okay, fine. Okay, tell me, Sita, clear? Any doubt?
Yes, sir. Yes.
Clear, right? Okay, fine. So that's it for today. Okay. Tomorrow you will have physical chemistry class. Okay. Fine.
Yes, sir.
Okay. So these are the examples we have from 18 electron rules. Okay. Practice it again. Then
Sure, sir.
tell me if you have any doubt. Okay.
Okay, sir.
Okay. Okay. Thank you. Huh. Bye.
Thank you so much, sir. Bye,
Hmm.
sir.
Bye.